We saw that powers of I follow the pattern I to the m equals I to the n if m minus n is a multiple of 4. And we also computed I to the first is I squared is negative 1, I to the third is negative I, and I to the fourth is 1. Using these together, we can compute I to any integer power. For example, I to the 16th equals I to the fourth, because 16 minus 4 equals 12 is a multiple of 4. And we know I to the fourth is just 1. So we get that I to the 16th is 1 as well. What about I to the 18th? Here, I to the 18th equals I squared, because 18 minus 2 is 16, which is also a multiple of 4. And since we know I squared is negative 1, we can conclude that I to the 18th is negative 1. But for larger powers, it gets harder to figure out how to reduce. But it can be helpful to reduce in multiple steps. For example, I to the 47th is I to the 7th, because 47 minus 7 is 40 is a multiple of 4. And I to the 7th is I to the 3rd, because 7 minus 3 is 4 is also a multiple of 4. And we know that I to the 3rd is negative I, so we can conclude that I to the 47th equals negative I. And if we want to do this all in one step instead of breaking it into multiple steps, we can use that I to the m equals I to the r if r is the remainder when we divide m by 4. For example, what if we want to find I to the 522nd? Dividing 522 by 4, we get a remainder r equals 2. So I to the 522 equals I squared is negative 1. So we found that I to the 522nd is just negative 1.